Hi, welcome back. We're going to talk about the Commodore 64 version of Dungeon Raider and some of the issues that I'm having. It's largely there and it's kind of working. The sound effects are messed up, but the issue I have at the moment is around level loading. So when I go into the game here, it loads entrance, and that takes some time. I mean, it's slower than the Apple II, noticeably slower, but it does work. The issue is it will take that amount of time for each additional level you have to access. So if I can explain that, each file has 5 maps built in. So in order to get to the 5th map in the row, it's got to take that delay to even start, 4 times to even start loading that level. Now, the file format is like this. So you have a 15 character header, which gives you the name of the map. And then you have a stream of text, which is the map itself. And then when that's finished, and that's obviously a fixed width, fixed length, because it's fixed width and height, you get the next room, next map, and so on and so on and so on. So it's like this. You've got map 1, 15 characters, and you've got a fixed length of map data, and so on and so on, depending on the number of files, number of maps per file, which is okay. So you end up with roughly 3.7K for 5 maps. Whoops. 5 maps per file. Okay, so in the case of the C64 loading, we have to pass. You have to start here and pass all of that file. So if you need the second one, which is there, you've got to go through that one, read character by character, before you get to there, bing, and then it says guard room, and you'll load the rest of it. The reason for that is the fseek command, which is available on the Apple, is not available on Commodore 64. I've tried to port a PET version with some assembly, but that didn't work. And there's no native support that I can find to seek to a particular file offset, which is a pain, because with the Apple one, you calculate the seek offset up here, file offset, based on the level size, and when you open the file, you then go straight to there. So it's there's no real difference. I mean, the timing difference is non-existent between the first one and the last one, because it goes straight to the start of the file. So I'm going to have to process these character by character or find a different way of doing it. So what I'm proposing to do now is I've created another Python script called mapper compressed. This is the original Python script, and it's all got a bit bent out of shape and messed up. I've completely redesigned that. It's much smaller, much more compact, and it does do compression. So the way that works is illustrated here. So if we look at the next page, this is what it will look like now, okay, which is obviously quite different. So the idea is that there'll be a marker of some kind, and I haven't buttoned this down completely, but there'll be a marker to say here's a new map. Then there'll be the 15 character map name, and then there'll be a compressed stream of data that comes out. All right, so this is what it'll look like. So the map marker, a 15 character padded map name, but then the map data is of variable length. So the way that works is by using by looking at the byte values coming in. So it'll go from a text file to a byte file. So I've got a example of the compressed file here. So you can see this is gibberish and it can't be printed by this editor, which is fine. So what we've got is anything that's below 127 is treated as raw data, as ASCII data, okay, or textual data. Type that properly. If it's over 127, then it's used as a byte count. So you get the byte that it is, take 127 off it, and the next character it sees is what's repeated by that number. And then you've got, I reckon 255 is pretty good as a marker. So this here could be 255, whatever it is. Just has to be outside this range. So as an example, byte character 133 with a single, let me just do that, a single hash after it would mean that will be repeated 6 times. So in the context of processing the map, oops, that's what it means. So you go from 6 chars in the uncompressed version to whatever it is on here, 2 chars. So that's quite a significant change. So the routine is fairly straightforward actually. It ended up being quite easy, whereby you find all the characters between space and 256, and then you loop round it and generate an array, generate a fine string where you start big and you go small. So as it focuses down, it looks at the largest amount, so 64 characters worth of repeats. If it's found that, then it'll do the replace. And then it will reduce the size of that find and do it again, reduce it, do it again, and then when it's finished, it'll go to the next character. This only works for characters that are 3 characters in length. So that's the minimum, because there's no point otherwise. If you look here, that 2 together is 2 bytes. Okay, that's also 2 bytes because you can represent that with the number and the type. So that's why it's 2 bytes here. This is also 2 bytes because you've got another number and one of those, but that number represents 4 lots. Okay, so you end up with reasonable compression. Let me show you that working. We're going to run that now, and that's doing the compression sweeps. I've set it to 3 maps per file. That's probably quite reasonable. So previously there were 21 files because there were 5 files plus another one. There's 101 levels, 101 maps. Here I set it to 3, and that 3 there results in 34 levels. Okay, so the compression bit, if we have a look at the launch stuff here, so I've got all the usual things. I've got a compress flag. It still does the check map, and you set up the maximum files, maximum maps per file, and you also specify the maximum compression length. So this is the number of characters that it's going to be. So if we have a look here, if I set that to 10, so the maximum number of repeated characters you can see is 10. When I run it, when I actually run it, it's really quick because it's doing a lot less processing. You can it then gives you a maximum file size. So the total file size is 46K, and the maximum file that is generated is 1.7K. So even that is 2K less than the size of the original. I mean, I haven't added the map level name, so it's a little off, but essentially that's 2K less than. Obviously, there's only 3 files here, not 3 maps, not 5. In fact, that's an interesting point. If I set this to 5, that will probably be a more accurate thing. If I then go down to 5 on there, we'll see it doing very little in the way of compression. So that's 3.1K with little compression. But there's still a bit. It's still knocking stuff off. That's 600 bytes like that. That's pretty good. So if we then change that and whack that right up to the maximum, I'm going to have 64K as the maximum. Then even with 5 maps per file, this will take a bit longer. Tested it like that, but in theory that should just be 21 files. There we go. It's 2.6K. So it's knocked 1.1K off the size, more or less, off the size of those files, which is pretty cool. That's still probably too large. So I think what I'm going to do is look to increase the number of files to a decreased number of maps per file to 3, and then we run that again. I'm going to run it from there, in fact. Almost 1,700 bytes. Let's say 1.7K for sake. So 1.7K, 34 files. It means a lot more files on disk, but that's not a huge problem. And then what I'm thinking is in the actual loader, the map loader, Currently, it does it byte by byte, but I don't want to be doing that. I mean, I could scan through the whole file, but what I might do is on one of the other functions here, the load screen, it uses this file open process to dump everything into a buffer. So if I can use this to inform the largest file, then I can potentially create read that data into a buffer internally in memory. So I load the file because the screen loading is quite quick. So I load the file, dump that into memory, and then scan from there. And I'm counting the number of exclamation marks, but they're going to be file markers, FF, whatever it's going to be, and it will count the number of those until it finds the file number that it needs. So okay, right, I'm going to load that now, and off you go, and then start processing the file, and it'll be processing it character by character in that screen buffer, or not screen buffer, in that buffer. The interesting thing is that buffer, because that's in memory, that actually should be quite quick. As you're essentially going through that string of bytes looking for the marker, the next thing you'll see is the map name. So when it starts up, it'll be quite quick. That's the intention. It's been a bit of a pain in the arse. I really like the file seek, but I'm trying to find the lowest common denominator with coding. And what I'll probably do is for version 1.1 of Dungeon Raider, I'm going to be modifying the Apple version to also use this compression, and hopefully that'll be even quicker. The speed is not an issue on the Apple II. It's remarkably good. It's just that I don't want any inconsistencies in code, differences or whatever. So yeah, the original file remains intact with all its weird foibles. So these are all the levels and stuff. That's fine. I've not changed any of that because that's a bit of a pain. But the stuff under the bonnet is going to be significantly different. Right now, I haven't got to a point where I've written the decoder, and I'll probably do that in a different program. I've got a utility program that I use to do some testing that's outside of all this main code, and I'll probably grab some of these compressed files and just dump that in there somewhere and test it that way, because that'll be easier. And then once I'm happy with that, I can go about replacing all of this crazy code up here. I mean, I've got to do something similar to that because I've got to work out the file number, but I don't really need to worry about a chunk, because all I've really got to do is figure out in this particular map what the offset marker is going to be. And that's it. So it's just a number, and that number, this stuff, where is it? Not there. This stuff all comes out, and it's all cushy. Now, what I don't have, what this does here is it will grab the level name and print that. So I'm going to have to work this out a little bit. I might keep it, actually, to be fair, because it's loading it byte by byte. With this command here. So yeah, that's a level decoding there. So I wouldn't have to change anything really. All I'd have to have is a big enough buffer and an index variable which looks at the offset of where I'm at in that buffer, and that as it winds through it, say, right, I've got depending on what it sees. If it's that, it carries on as normal. If it's that, then it's essentially got to go into a little loop and generate that as it goes. So there'll be essentially this bit here will change, and there'll be a loop in there. So there'll be a loop encapsulating all of it, and it will essentially say, if I've got a repeater, i.e. we're greater than 127, then here's the character, the next character, and go and continue on this loop 20 times or however many it is, and then the rest of it hopefully will work. It's been a bit of a nightmare, I've got to be honest, but it is what it is. I suppose I don't have to do all this passing up here. I could just pass the file up here in a little loop like this. Where's it gone? Like this, until I find that map marker. If it's at the start, it's going to be the same. So just straight there. Oh, I've seen the map marker. I'll carry on. You're now at the right place. If it's not, then it will continue reading data in from that buffer, or scanning the data in the buffer until it finds that marker. That's the plan. I'll let you know how it goes. See you next time. Cheers.